Hello, and welcome to Diana's Makers Chat, episode 203. I'd like to give a reflection today of NASA's panel regarding the space program and the new space vehicle. The thing is, I hope they get the February 20th fixed date to get the two assets on there down, and that they do follow through with getting basically everything worked out. But what I'm really surprised about is simply this. When I was vice president of Society for Computer Simulation during the 90s and chairman of emergency management for Society for Computer Simulation during the 90s, I had friends who worked at Boeing, friends that worked on the ISS, International Space Station, and the 777 project. And both of them took a lot of pride in the ISS project. It was a lot of work and there's a lot of stress, as one friend sort of shared with me like that, though. And even the 777 project, I wonder if they're, excuse me, if they were alive today, what would they think of this? I mean, and really, if my dad was alive today, what would he think of this? Because what happens here is the problem is, I see it as a case of not understanding simple engineering. What happens, so is I wonder, I'm sure a lot of the people work on the program or have good engineering degrees from good universities. However, I wonder how many of them still remember the old school engineering. How many of you working on the space program have ever changed your tire in your car? How many of you know what a quarter ton jack is and why you keep that in the trunk of your car or in the back of your truck rather than using the jack that they give you? How many of you know how to take off the bolts, and how do you take off a machine bolt? Do you know about using a lever arm of a pipe? Or something, let's go to something simpler. Okay, how many of you know how to use this? This is a caliper. And what happens, you take it and you measure. And how many of you know what this part's for? This is to measure the inside. This is to measure the outside. Well, now when you measure, do you do a direct reading like this, or do you turn it on? Well, I actually showed one that does have a battery to illustrate a point. When you do stuff, you've got to make sure you check your tools, make sure they work. So this one works. Let's turn it on. And okay, let's go to reading. Okay, well, let's say someone's taking a read and says, well, it's 2.87. Well, you may agree to work in the metric system, but when I worked in the 90s, we did it this way. What happens is you say the units 2.87 inches, or if you want to change it, you can change it. So let's see, change it. Okay, you press the button to go to millimeters, 72.9 millimeters. But you say the units. Because, and the other important part of this too is remember the zero. Like this. And why am I saying stuff like this? Because when I look at the space program, we're making mistakes we shouldn't be making. I mean, the Chinese are going to beat us to the moon, and what are we going to be? We landing on the moon third, behind the Chinese, Russia, or maybe even India, heaven forbid. I mean, God. The other thing is basic engineering. When I had this ruler was $7.95. How many of you who have engineering degrees watching and working in a space program recognize what this ruler is? Did you say architect's ruler? Great. At least you know, you still remember your basic engineering. Do you know how to use it? For example, if I were to say, well, let's see you do something that's 1 to 20, or something that's basically 1 to 28, or what about 1 to 92? So how would you do this? How would you do this? 1 3/8, 1 quarter, 3/32, 16ths. Would you know how to scale up using this ruler? And also, do you know enough to respect your equipment? to always put it back in the case and always put it in a safe place. A second point, another point. Everyone is trained nowadays, even at my alma mater, Udall Parkside, to use Android. How many of you still know how to use a scientific calculator? And how many of you know how to change from radians to gradients and decimal and know the difference, as well as changing from binary to hex to octal? Yes, octal, because in some machines you do have to use octal. And the other part, how many of you still remember how to use a programmable calculator? This is an HP 48, but also I have a TI 85, because sometimes you can get more things done using this than trying to write a C program using the various C compilers, which take a lot of space, and the computers take a lot of time. You can use this in the lab. Fine. Another thing is, how many remember this? Statler-Mars compass set. And let's open this up a little bit, and we'll see what this contains. It's been a while since I opened this, but let's see. Well, I have let me get out another compass set, which is equivalent to Statler-Mars. This one is put out by the Chinese. This is from Alibaba. French curve, template, 35-degree triangle, 45-degree triangle, 30-60 triangle. Compasses, compass extender, pencil sharpener, 3 types of pens, pencils, 2H, 2D, 2B, also compass points, also special laser. And many women know, basically, who work in engineering, this is only used for your pencils. And for those who are transitioning, do not use the same thing for your eyeliner. For those who are engineers who are transitioning, no, because these contain lead, and you could really hurt your eyes if you get lead in it. So you keep a separate pencil sharpener for your makeup and separate pencil sharpener for your compasses. And the other thing is, how many of you have ever used this? A wire crimper and also a wire stripper. This one, and know what someone means when they say 20 gauge, 22 gauge, 24 gauge, 26 gauge, 28 gauge, and 30 gauge. Do you really know how to strip wire? Have you really worked on a breadboard? Or multifaceted screwdriver. How many of you know this is a Phillips? This is a flathead. This is a hex head. And let's go on just a few more things. When you do circuit analysis and you're using a computer, how many of you have used this, a logic analyzer, to probe this into a circuit and analyze the logic signals if you don't have a multi-channel oscilloscope? And last but not least, how many of you have ever used a special computer repair kit or chip assembly repair kit and realize, yes, this looks like a spatula, but you use this to open up your computer, but the spatula is still the same. Chip extractors, multiple computers, a pin holder to open the pins, magnetic device to magnetize your tools. And let's see, let me pull this out here and show you part of it here, some of it over here, the screws. And my point is about this is simply this. Although in engineering, it's cool for everyone to say, well, oh, great, I know Android. I know how to do this. I can do this through Android. Why can't we just have an app where we just push buttons on a cell phone and do this thing for us? Guys, you got to do the work. You got to do it old school. You got to learn how to change your tires, take the lug nuts off, and understand the reason why you get a hollow pipe with the extended arm to break a machine bolted pipe to give yourself a lever arm, also how to crimp wire, and again, how to use a compass set, and how to use, let me open this up again. No, and how to use a compass set. Now, what happens when people wonder why are the Chinese jumping so far ahead of us? I can see the reason why. This compass set, got a great thing to take along with your design and other stuff. It competes with Staedtler Mars. I mean, basically, but you know, like when I talk with a friend of mine who teaches, he's the same age as I am, and basically he's 62 as I am. It's like basically, I'm surprised what I find out, and also how to use the compass set. When I went to school, this is common use whether you're in computer science or not. And even in computer science, you had to learn physics 201, 202 with calculus. Nowadays, that's not recommended at my school. They dropped that requirement. How can you do computer science and circuits if you don't know physics and you don't understand Ohm's law, what a whetstone bridge is, what an amplifier is, what a 555, what a monostable multivibrator is, a one-shot, stable mode, monostable mode. I gotta catch my breath. And when you look at this stuff, again, this is bought on AliExpress. This is made in China. What happens, and also, how many of you actually have a special magnifying glass that comes out like this, so that when you do work on projects, you can look at it, because you have to remember, although some of you may be in your 20s, some of you may be in 30s, your eyes aren't going to be that good for too long, and also it's good to protect your eyes when you're doing this stuff. And finally, how many of the people on Spaceport understand about using a vise? This is a vise to hold a breadboard. You move it back and forth. Also has a section to hold a solder station. Along with helping hands and when I watch YouTube videos, many people don't understand what this is. And why is there a magnifying glass? Because what happens, they help when you make connections with the breadboard. And this goes to an important point. When I listen to the NASA panel, they say they're going to work the problem. Great. I hope you guys do. I hope you guys work the problem the way my dad remembered it when he watched the movie Apollo 13. Because when the movie first came out, I wasn't sure whether I should show it to my dad, because he worked in the space program, and he is very upset about the error that happened in Apollo 13, and he's glad the astronauts came back alive like that, though. But when I showed him the movie, he said no. I said definitely, because he was telling me stuff. He said, and what happened was he was telling me things like, well, hold on, let me get one other prop here, just a minute here. In the movie Apollo 13. Okay, let's go old school. This is a 12-year-old Black & Decker coffee maker. Runs on 15 amps of power or less. Now, on Apollo 13, why did the person who was at the meeting show this type of coffee maker? Say, well, we only have enough power to power this coffee to make a pot of coffee. Because what happens, you have to work with the conditions you have. You can't work with the simulator. The simulator is not always right. The simulator overestimates. You have to work with this. And what happens, you have to realize, if you don't have 15 amps, this thing's not going to make coffee. And just like on Apollo 13, if they shot the 15 amps and doing a one shot right away, they never would have came back to Earth alive. They had to do it in steps. So, to what I say about basically the panel, please work better. Please talk to us old engineers, many of us who are boldies, some of us who are disabled. I'm on disability because I have health issues. Without insurance, my health insurance would cost $30,000 a year. And reason why I can do some of this is because I do have health insurance that allows me to speak up and to share ideas. But if I didn't have the health insurance, I'd be a lug on the bed, or I might be dead already. But the point is, you guys got to remember, you got to get your hands dirty. You can't have it all your text do it. Do this. Like, for example, let me give you a very simple example. Assume this is a pipe. You want to connect two pipes together, and you're putting on latex tape, okay? How do you put the latex tape on so when you screw this on, that the latex tape forms a tight seal between the gaskets for gas? You put the tape on counterclockwise, because when you turn this, you're going to turn this clockwise. Because remember, lefty loosey, righty tighty. So you put the tape on counterclockwise, and then you turn this clockwise. And that way, what happens if you do it the other way? Well, when you turn this, you're going to have a gap, and you're going to have gas hissing. You're going to lose pressure. You're going to lose oxygen. And another point, like my dad mentioned to me when he saw Apollo 13, what he said is basically is, even before the movie Apollo 13, when I was in high school, he said he liked it that one physics teacher had talked about a physical fact known as the coefficient of linear expansion. Coefficient of linear expansion. What does that mean? Well, most things when they get hot, they expand. When they get cold, they shrink. Water's just the opposite. When water gets cold, it expands. It's like, so if you get water from ice tray, can't get out, you run water on it. Then when it gets warmer, it shrinks and pops out of the ice tray. Well, what happens? Why do you need to consider this? Because when you're in space, like many astronauts said, one side is hotter than the oven, the other side is cooler than the coolest freezer you'll ever run into. And what happens when you have a part? Well, one part on the side, this is hot, this part's going to expand, the other part's going to shrink. What happens if you don't plan for coefficient of linear expansion? Crack. You have loss of pressure, loss of fuel, loss of oxygen. And what happens? It can make a capsule unsafe, especially if it's a critical systems. We need to get back to understanding these basic engineers, because the way I think engineers taught in schools nowadays, strictly on Android and other stuff. No, if you really want to fix this problem with the space shuttle, with the space capsule, you need people to understand how to do it old school. Compasses, scientific calculator, not an Android app, to know how to think of the equations and write the equations as an understanding relationship. How to get the hands dirty using a crimper and a light bulb test. Also, how to realize how to go inside the unit and use a logic analyzer. Again, and how to make thumbnail sketches and on the lab site or on the building site. So basically, you can get things done sooner than waiting for 2 weeks for someone to do a CAD using an architect's ruler. In addition, someone knowing how to use a programmable calculator, because sometimes when you try to write a program in C, Python, Julia, or something else, these you can't bring these on the lab floor. It's like my dad told me one time when he worked at one company. They had all sorts of problems because basically when they had to do quality control, basically they had these guys using out of calibration side rules. What did my dad do? Well, in 1961, what happened was he asked the company to buy the guys on shop floor calculators so they could do quality control the calculations from Sears Roebucks. Well, what happens? The one director of engineering said, "Well, no, they can still use the side rule." Well, what did my dad do? He bought it out of his own money. He gave it to the guys in the shop. And what happens in Pennsylvania? My dad, at that time, was the first person who was quote executive, but who was nominated by the union to become a president of a workers' union, because he would go down and put on a jumpsuit. He would get his hands dirty. He would put on goggles. He would put on steel-toed shoes. He just didn't sit in his office. He did it. So guys, all of you work as a space program, stop sitting in your offices, get jumpsuits, get steel-toed shoes, get goggles. If you have to buy you guys a calculator to make sure that they can do the quality control work properly, you buy it out of your own salary. And also, you don't need to call CBS News to give you a pat on the back. That should be part of the pride of your job working for your team. In addition, if you guys need special lens set, buy it. If they need a programmable calculator that stays at work area, buy it. They need a logic analyzer, buy it. They need a compass set, buy it. And you need a ruler, buy it. And you don't buy the stuff through GAO. Like with me, I'm on disability. I have a very limited monthly budget, and I'm lucky that and sometimes the last 2 weeks is very hard for me. So I have to watch when I buy stuff. So when I buy stuff, this thing I actually bought at Goodwill. We bought at Goodwill. This I bought on Amazon. This I bought at UW Parkside's College Bookstore. This the Publishers Clearinghouse. This through Amazon. And the Logic Analyzer, let me get that out, along with many other stuff through Alibaba, Temu, AliExpress. And also I buy through other vendors. I buy through DigiKey, I buy through Electronics Express, buy through Microchip. However, the thing is, when I buy stuff, I don't have a lot of money to do my projects. So I mean, basically, I don't you can't think of, people can't think of it as, well, it's not my money. It is your money. And also when they think, well, okay, well, it's hard if we pay $2,000 for a hammer. No, it's not. And they say, well, we're buying towards quality. Well, okay, well, go to Harbor Freight, look at the hammer, or even like go to Alibaba or AliExpress, look at this, or go to Amazon. But the point is, there are many manufacturers, many medium and small sized businesses that make good stuff like this, but the problem is that that's sort of blocked out because the GAO system is too hard for them to get into, and even the CHIP Act. I looked at the CHIP Act. God, this long of a preamble. I was thinking, how do I apply for this? And it's like, well, you got to read this preamble, and it's like, oh, and then you got initial in it. It's like, oh my God, I'm on disability. I'm a researcher, vice president, engineer. I'm not an attorney from Harvard Law, but I would need someone from Harvard Law, Yale Law to read this. And I sent it to my attorney, and she said, "Oh my God," I said, "this is what you have to do to get grant for the CHIP Act." She says, "What type of program is this, and how much money are they going to?" I said, "I don't know." I says, and she said, "Well, I would find another way. This is way too complicated." And that's what, hint, you got to make this stuff simple for engineers, researchers, even bold engineers, hobbyists to understand this and that, though. And also, when executive summary, hint, from my University of Phoenix day in the MBA program and the doctoral in management organizational behavior program, an executive summary is no longer than 2 pages. 2 pages, not this. We're not looking about how well someone can write War and Peace. 2 pages. So the Old Man and the Sea, not War and Peace. And even for the packet, the Old Man and the Sea, not War and Peace. Well, so for the folks at NASA, I hope you succeed, but you guys got to get back to getting back to old school, and you got to get people that are willing to go down in the trenches, get their hands dirty, and check that wiring, check that tubing. And also, you gotta have people that know how to change their own tires and even jumpstart their own cars. And also some of the older people who actually still remember how to jumpstart a car when you had a carburetor, where you put gas in the carburetor and you had a blanket just in case it caught on fire to smother it out. And it's not a wet blanket because you cause a big but and so you need to get those types of people. And the problem is, if you're going to rely on people just punching Android or saying, "Well, I have to do this, I have to do this in Python, I have to do this in Julia," and they don't know how to do it this way, they can't go on the floor, they can't, they don't know how to use a breadboard or even do a test breadboard socket. Um, we're gonna end up being last till we land on the moon. So basically, please, 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 please. I hope this serves as a wake-up call and a kick in the pants that we have to get back to people, old school engineers who know how to get their job done. And some of these old school engineers do not have A averages. Some of them have C averages. Some of them have B averages. The reason why is because they did projects outside of class because they were bored with the class material. And those are the ones you need to talk to. The B and C students who were bored with it and did their own projects, who made their own amplifiers, who made their own stereo systems, who make their own computers, who make their own test beds. So let me know what you think. You can reach me on X at Diana1A or leave comments on YouTube. This has been Diana's Makerspace, episode 203.